Okay. 3,
I hope I do this.
2, 1. Good morning, good day, and good evening. We're not starting again this time, so welcome to the show. You never saw what happened 10 seconds ago. It doesn't matter. So I've done a video the past couple of years talking about the 2038 problem, and today we have the person on the show who has been writing these posts and doing a lot of this work, who I was told I pronounced your name incorrectly. So how about you introduce yourself and we'll go from there.
Yeah, so when you pronounce it in German way, I'm Bernhard, I'm Wiedemann. But you might go with the English version of Bernhard or something. That's fine. Anyway.
So introduce yourself, tell us what you
do. I work for SUSE since 2010. That's over 15 years by now. So quite some time. And I work on OpenSUSE and a lot of other stuff. At some point, I did the OpenQA test automation. That's very important for our Tumbleweed rolling release distribution now, but other people take care of that now. So my baby got adopted. It's a strange feeling. It's good. And then I started to work on reproducible builds, and that means testing that you can build software and build it later and still get the same results. And there I found the problem we want to talk about today, but maybe we want to go a bit more basic.
Yeah, I think a good place to start is just explaining what the 2038 problem is for anyone who's completely out of the loop.
Yeah, computers track time. For example, if you start a download, you want to know how long does it take and have a percentage meter based on previous download speed. And for that, you need a clock. And to calculate differences on the clock, it's very easy if you have an integer for the start and an integer for the end, and you just do subtraction of one and the other and have a difference. But for that, your integer needs to start somewhere, and that somewhere was 1970 for the Unix folks.
Midnight, January 1st, 1970.
Exactly. And for some reason, they made it a signed integer, so they could represent dates from 1901, because maybe you import old files from older machines that were not Unix and whatever. I have Git repos with Git commits from the 90s when Git wasn't around, because I imported old stuff. Might be a consideration. We don't know.
That would make the most sense.
It's just how they did it. And that's original 32-bit counter, because that was way enough for the far future back in the 70s.
Yeah, if you're writing code in the 70s, it's a reasonable assumption that nobody's going to be using that code 60 years later.
Yeah, not only that, compilers back then were much simpler. I'm not sure they even had this 64-bit integer type built in. So if you wanted to work with 64-bit numbers, then you would have to do some more involved arithmetics somewhere. So everything was complicated if you did 64 bits, and of course it's slower. You want to do the difference of two numbers, and if you have to do more operations, then it's slower, and machines back then were much smaller and slower. And so, they saved some space and time.
Problem is there's numbers being used for a little bit longer than anyone would have anticipated.
Yeah, I'm not sure what they thought, how long computers will be around, but they're still around, and even more than back then. There was some quote from some IBM guy who said, maybe there will be 6 computers somewhere in the world. And
there's at least 6. He wasn't too far off.
But back then computers were very big and very expensive, and these days that's not the case anymore. So you have these counters of seconds since 1970, and they keep ticking, and another second, and another second, and +1 and +1. And soon I think we reach the 2 billion seconds. And shortly after 2 billion, we will reach this number. When you write it in hexadecimal, it's 7FFFF, FFFF, so 7F. That's 32 bits, no, 31 bits. And when Z gets a +1, then it rolls over and becomes a negative number again to represent 1901. Yeah, and that can cause trouble for systems because if you have your download running and want to calculate the difference between two numbers, and suddenly the difference is not 3 seconds but 4 billion seconds, oops, that will be a minor inconvenience to you, but there might be other machines that will have stronger failure modes. And if nobody tests these and checks the code, and things can fail.
The specific point this runs out is 3:14 and 7 seconds, 19th of January 2038. For anyone who really cares about it, it's 2.147-ish billion. You can just look up 2038 problem. I don't want to read out the entire number. It's around about that point is where things run out.
Yeah, you can use a calculator and calculate 2 to the power of 31. And
well, you could do that, yes.
Throw that into a date command with the date -d, add sign and the number, and yeah.
Now, the 2038 problem is often compared with Y2K, also known as the year 2000 problem. And I feel like a lot of people sort of... I've seen discussions about the year 2038 problem. People sort of undervalue the problem because of what people in the general public saw with Y2K, where a lot of people saw the end result where a lot of work had gone into fixing it, so people now assume that nothing ever actually happened there.
Yeah, that's sort of paradox, huh? Where you spend so much effort and go into all the code and review it and fix things, and after you have spent all of this effort, you did everything keeps working. Very nice. Yeah, it's like every day you take out your toothbrush and brush your teeth, and what's this effort for? The teeth are fine, so nothing ever happened to your teeth. So yeah, I think it could have been worse if no effort had ever been spent. And
I think
that's only one aspect.
Oh, go on.
1999 was a different time. There was no iPhone and no Raspberry Pi. So, and computers were usually, I did have a laptop, but this was like 3 and something kilograms, and it had 32 megabytes of RAM and a small hard drive, and you hardly could run Firefox on it. And real computers were these big boxes and heavy, and so there were a lot fewer computers and fewer servers and smaller machines with less RAM and less flash storage. So you had smaller programs with less code and even less coders. There's over twice the number of software developers these days. And so all that means there's a lot more code and more involved code and more code that you didn't write yourself because other people wrote it, and the whole open source thing took off since the 2000s.
Right, you're relying on libraries that rely on libraries that rely on libraries. The JavaScript environment is really bad for this. You'll see dependency chains that go 30 packages deep.
Yeah, like if you ever done a Hello World NPM thing, that's like hundreds of megabytes. And there's a lot of code from other people in there, and you didn't review that, so you don't know if there's an issue.
So even if your code is compliant, there might be somewhere down the dependency line where somebody did something, and like, how are you going to find that?
Yeah, exactly. So you need to take all the source code and somehow review it. But yeah, there might be some automatic ways because it's made to be machine readable. That's a nice thing about source code. So there's hope that we can get some linters or compiler warnings about these things. And there's one thing. Oh yeah, why do we count seconds? There was a story where people wanted to issue certificates for their cloud environment, and they wanted to be valid for 1 year. So what did they do? They didn't use the seconds, but they just incremented year by 1, year plus 1. And that worked for a year and another. And one day it failed. You know which day it was? It was February 29th. Because when you do year plus 1, there's no February 29th. Suddenly, yeah. And these kinds of things you can avoid if you just have seconds, because then you do 60 times 60 times 24 times 365, and then you have the number of seconds you want to add.
I know some some time nerd is going to comment in the comment section about leap seconds. We're not talking about leap seconds right now. These are also a thing.
Yeah, there was also, I remember an issue in the Linux kernel when a hosting provider wrote, we measured power usage went up at this moment because all our servers had this leap second issue. And you need to reboot it once to get back to normal. That was a decade ago or something.
One of the other problems that didn't exist when Y2K rolled around is devices were far less interconnected. So it's not just that there were less devices, it's, you might have had a device, but that device was offline, that device was just its own thing. Now, you might have a laptop that's connecting out to, 20 or 30 different servers all at once, and all of those are also important to make sure things are still working as well.
Yeah, exactly. In 2000, I had a dial-up modem with 56 kilobit, and I dialed in, fetched my mail, and went out again to not incur charges per the minute. And that was a very different time to use the internet. So, yeah, and only the happy ones had DSL.
I think part of why people undervalue this as a problem is because of how sort of extravagant some of the reporting on what would have happened was. Planes were going to fall out of the sky, nuclear bombs were going to be launched because the computing systems would just malfunction, like things that just were not possible with how those systems were built. Like, a plane wasn't going to fall out of the sky if the GPS system broke. Because of that, people now assume, maybe now it's going to be different, but people assume that because the worst things didn't happen, nothing happened. But things did actually happen that weren't patched. There are some small video rental stores, for example, that sent out late fees that were hundreds of thousands of dollars because, you didn't return it since 1901.
Yeah, so something did happen, but machines were less interconnected, and maybe there was more humans in the loop these days. If you have AI and it's not trained on these kinds of things, because why should it? But you don't know. There's so much electronics these days in all the places, in cars, in smart TVs, in home routers, in Raspberry Pis embedded anywhere. It's so much stuff.
So one thing I often hear, which is obviously incorrect if you know what's going on, but I often hear people say, this isn't a problem anymore because we're not using 32-bit systems. That's obviously not correct. But why is that not correct?
So there's one part that is improved for 64-bit systems. That's in glibc. You have this type called time_t. And this time t is 64 bits on 64-bit systems. So that part is fine. So everywhere where your programs use time t correctly, everywhere, that's dealt with. That's fine. But then you start sending stuff over the network, and your network packet has a defined binary structure, and maybe that defined binary structure was made at a time when people thought, 32 bits is enough for this kind of thing. And like SNMP did it, or this XML RPC, also called SOAP, and that has types for characters and for strings and for 32-bit ins, but I think it didn't have a type for 64-bit ins. So if you transmit a time and just use trivial 32-bit int to transfer it, might run into trouble.
Mm-hmm.
So there's these transfer formats or file storage formats. MariaDB had this problem where they store timestamps somewhere and they have a fixed binary format, and they didn't want to change it to 64-bit because that would break backward compatibility. So they did a different fix, which was to redefine it as unsigned in. So it runs for another 68 years. Yeah, that's fine. That's a long time in the future, you know.
Right. Surely no one's going to be using it in 64 years from now.
Hope. No, I think they can figure out some other solution.
So I was going to ask, there are temporary stopgaps that can be done, like dropping the signed integer.
Yeah, replacing it with an unsigned integer. That's another project just did that last week. That was the SOAP something. They also had some log keeping internal stuff, but it was a binary format, 32-bit, and they didn't want to mess with backward compatibility. So they just said, okay, it's not signed int anymore. No, it's unsigned int. And all the previous values keep working because the top bit is 0 still at the moment. And once there's a 1 bit, hopefully everyone will have upgraded. Mm-hmm. It's still nearly 12 years, not anymore. Mm-hmm. Yeah, every year on January the 19th, I say, let's remind people that next year it's only 11 years left.
Maybe at some point people will start, caring about the problem. Maybe.
No, they already start. So
okay.
I see patches being done. When I did the post, someone said, there was a patch in Grub with a new release recently, and Grub does this own calculation for conversion of timestamps to an actual date because they don't have an operating system to rely on at that point. And they fixed their calculations there.
Now, 64-bit might not sound like it's that much larger than 32-bit, but the number, because it is, you do this to a power of 2, right? Just how long is this for anyone who might not really know how little of a problem it is anymore if you go with a 64-bit number?
Yeah, let's say long enough. The sun will be out and the Big Bang will long be forgotten. And maybe you can even reference timestamps before the Big Bang, which nobody ever needs, but yeah. The 0 is still at 1970.
Basically, you have more than enough numbers at that point where it's... Look, if we outlive the current universe and move to another universe and somehow are still running the same software that hasn't been updated in billions of years, I guess they can worry about it then.
Yeah, I think we will run out of IPv6 addresses before that.
Maybe we'll finally make IPv6 the standard by then.
Yeah, it's at 50% adoption or something. I'm still waiting for someone to run an IPv6 only server for something that people really want, like, that adult stuff. And then people will be incentivized to finally adopt IPv6.
Yeah, I guess that's what we do. So, why did you start getting interested in identifying these problems?
Yeah, let's say I like things to be correct, and I did this whole operating system automated testing thing to ensure that our OpenSUSE releases are correct and working. And then I tested for reproducible builds where I found actual bugs in the build process. Where sometimes, there was an error and we didn't check for it. So, no, you have 40 man pages binaries in your package and you never noticed because it's only randomly 10% of the time or something. And I found these things and for the reproducible builds we tested, in the future you can still get the same binaries as today because sometimes there's a year embedded in, that's not copyright 2027 because you put the current year into the generated file, and that's weird, but people do that kinds of stuff, or just timestamps. And I noticed that some packages failed when I built them past 2038. And I looked into that and found that there's actual instances of this issue even on x86 64. So even with a large time t, but people convert this time t to integer and do things with it because int is the default type in C programs.
And is that a 32-bit int?
Yes.
Right.
Standard int in C is 32-bit. There's a long type, and on 64-bit systems, long is 64-bit, but on 32-bit systems, long is 32-bit. So it's not enough for tracking time. And if you really want to be sure, you use long, and then it's definitely 64-bit.
Why are they doing those time to int conversions?
Maybe they just didn't think about the type thing. Or there's the standard C functions, for example. There's one called A to I, ASCII to integer, and that returns an integer from an ASCII, where you have maybe your config file or your HTTP request with some number, and you get this number in, and you throw it at your A to I function, and it gives you back your integer that got converted out, and it works fine now. And after 2038, it doesn't work.
Right.
So you need to use the right function, the A2L, the long version of it. And then I did some patches in that direction as well. And there's some pending patches too.
So what are you mentioned the time t to int conversions. What are other common areas you tend to run into that mistakes crop up with?
Yeah, you can have the other direction. So let's say you have a network protocol, you have a server and a client, and you want to communicate timestamps between these one. Then your server has this time t, and it needs to convert it to something you can send over the network, which is either an ASCII string of your number or a binary representation of your number. And then the client has to do the opposite conversion of this binary ASCII into your time t. And if at some point of this conversion on one side or the other side, you need to get both right for this transfer to work. So you have this time t to int and int to time t, and both have to use actually 64-bit integers in their conversions and in their transfer protocol. Only then. So there's a lot of things you need to get right, and if one of these transfer steps is wrong, and maybe the client writes a file for storage, for logging, whatever. And if there's a printf function where you can put in %i, and %i expects an integer argument, and there's this kind of there's language defaults, and a lot of this language defaults say int is the default, and int is the default. It's easy to use, but wrong for times.
So it's not necessarily directly storing the numbers that you tend to see problems with. It's more the conversion between types for moving that number around between functions and moving that number between networks.
That's one usual reason for that. Yes.
So as you've been finding these problems and reporting them to upstream projects, what has been the response you've gotten from developers in some of these projects?
Different. So some just say, oh, here's a nice merge request. Let's merge it. Blah, blah. If they're nice, they even throw in a thanks exclamation mark and a smiley or something. And others, I don't hear anything back because it's an orphan project and they don't care about the software anymore. That's how open source is. And maybe in a few cases they said, oh, there's a time traveler and why is this clock on the year 2039? And something is wrong with the system and he should check his system instead. I have some copy pasta that I throw in there why I'm testing with a clock to the future, and that helps avoid some of this confusion.
Right, because I could imagine, especially for things that involve like, SSL certs, they're like, okay, you've got the time set wrong. Obviously, that's not going to work, right?
Yes, that's a completely different part that plays into testing because as these certificates, they can expire next year.
Right.
And then usually it's in the test part of the software. So when I do these build tests for reproducibles, there's a build part where it unpacks a tarball, runs a build, installs the binaries, and then it runs tests. And these tests, they use pre-generated certificates, and these SSL certificates, they always have an expiry date. And if it's 2027, then it stops working next year. To run these tests, the software itself won't be fine, but we can't test because if he sets the date to 2038, then there will still be the expired certificate, and that sort of blocks the view on the other issues that might be hidden behind it.
Well, how do you deal with that problem?
Not yet. I find issues for upstreams and then maybe generate these certificates on the fly at runtime, so they're always valid for yet another year, or generate certificates that are valid until year 3000. That's someone else's problem then, or so there's different solutions, and sometimes I send them pull requests or let them decide how they want to solve it. And some accept it, some don't. It's like mix of outcomes. But it's still a problem. There's one idea that maybe we could patch our OpenSSL and GNU-TLS and Mozilla NSS and everyone who does this kind of certificate expiry checks and have some common way to say, okay, here's the certificate, but please consider expiry as if today was this other date. And then they virtually never expire, and then we can test for this, these other issues.
You mentioned some people have been confused about why your date is set to sometime in the future. Have you seen some anyone with confusion about why you're even looking for these problems and why you kind of like why it even matters to fix this now? Because I'm sure some people will think, oh, the problem's X number of years away, 12 years as of recording, however many as of when you're watching this. Like that's a problem for later.
Yeah, I've had one or two people with replies like, I acknowledge it's a problem, but I have much more urgent things to do right now because maybe there's an embargoed security bug and he has to solve it urgently and hit a deadline. His company runs out of money and so there's practical concerns, and people don't always prioritize fixing things that only are a problem in 10 years from now.
Now, obviously, you can really only test stuff that is open source. There's a whole world of proprietary software that very well can have all of these same problems that I would hope the companies that are involved in this are dealing with and testing, but we really have no idea to know what's actually going on there.
Yes, But of course, you could do some black box testing. Black box testing where you have your Windows and your proprietary software on top of it, and you tell your Windows, okay, disable NTP, and now your date is set to 2039, and just see how it goes.
That'll obviously work
this kind
for
of
runtime problems, but build time issues, you're not going to be able to do that. Yeah.
Yeah, because you don't build it. You don't even have the sources to build it. That's for the vendors to figure out, because they make it proprietary. They get all the problems from that.
So you're only kind of one person doing this. If somebody else wanted to help out, find problems in maybe software they make themselves or software they use, what's the easiest way someone can go about actually, doing a test like this?
Yeah, you could test with your system clock set, or in a VM. It's even easier, because then there's a KVM option where you say -RTC space base equals and give it a timestamp. Then your VM starts running at that time, or you just do it interactively in the VM and set the time, and then you can play around there with stuff. So that's how I do it for my build tests, to run in KVM anyway, to have some isolation. And that would be a way, or just review your code. You can grep for time t and functions using time. There are not that many, but should hopefully become easier soon when we get some compiler patches. There's some work happening on GCC. We want to get warnings for this time t to in conversion and for the in to time t conversion. And when we have these both, then you can compile your server source code and your client source code and get warnings for the actual things, and maybe even declare these warnings as errors. So it throws in your face when you try to compile a program. And says, okay, in this place you do this conversion, and you need to be very sure that it's actually what you meant, and that's safe for 2039.
I did see some discussion on, I don't remember which one it was, whether it was time t to int or int to time t, where one of the maintainers was saying it would make more sense to have that warning closer to language front ends rather than having it where they are.
Yeah, let's call it an implementation detail, because these compilers have internal structures where they have a front end that parses the actual language constructs, and then they have an intermediate language, and from that intermediate language they construct the machine code output and optimize and whatever, and they discuss where in the stack of within the compiler they put the warnings. But in the end, I want a warning, and wherever it ends up, it's fine.
Hopefully that can happen, because at least having a warning there, it can give you some indication you're doing something wrong, because you might have assumed that, especially in a large code base that you may not be the only developer on, that there are none of these mistakes. Like, you may personally have not made a mistake, but if you're dealing with a million-line code base that has 30 other people working on it, it's very easy that somebody else has made that and nobody has reviewed that part of the code yet.
Yeah, there's different review cultures in different parts of the software world, let's say. And when for reproducible bits, I've done a lot of patches, like over 2,000. And in one instance, I noticed that I sent a pull request, and there was a typo that meant there was a syntax error to compile it all, and they just merged it. And only half a year later, I noticed that it didn't compile, and then I sent a fix up to thing, and they also merged it. So there can be very little review and looking at things that go in, and other projects are better. They actually discuss things and go back and forth and improve things and make things really nice, but that's not the standard everywhere.
So we kind of touched on this earlier, but there is the possibility that if this is not taken seriously, this could be a much larger problem than we saw with Y2K. And especially, we can talk about how many computers there are now, that's not slowing down. There are parts of the world that didn't really have internet connections until very recently that are now coming online, places like India that have massive populations, and over the next 10 years there's going to be a massive boom of massive boom of like development there, more computers there, and that's going to bring a lot more people that are going to be affected by this. There's only going to be more computers, then you have all of the data center build outs that are happening. By 2038, like, who knows how many computers there will be by then, let alone how much more connectivity there are between these devices as well.
Yeah, if you say computer, you also need to consider smartphones, which are computers by all means, because there's a Linux kernel running on it and some user space. And so there's a lot of these billions of devices. And when you think about the physical world, like our city, they got new streetcars or tram. And the previous ones that are still going when there's busy hours, they were from the 70s. And you can see how long this stuff keeps around. And yeah, they got some electronic upgrades over the time. But these days they have screens and showing next station and when they will be there. So they do have a clock. And I'm not sure if anyone ever tested if they will keep working after 2039, because they will definitely be going, the new ones, after that date, and can expect these things. So there's long-lived hardware out there, and that will have trouble. And these small devices that get replaced maybe slightly more often, but some stuff it just keeps running, and you have it somewhere, or not you, but institutions. Institutions have this kind of thing where it gets set up by someone and it gets put there and it runs and runs, and nobody remembers how it was done, but it keeps working and doing useful stuff.
Right, somebody has a Debian server sitting in a closet somewhere. They know it's powering something. They don't know who put it there, but it's very important.
Yeah, and these days it's not Debian servers, but Raspberry Pi size Debian servers. And they keep running this kind of thing. And if you just have them internally and not exposed to the internet, it's not even that big of a threat security-wise. So I can imagine things to keep running for another 12 years and be forgotten about. And at some point, yeah, it might break. Tough luck.
But the closer we get to this, like the closer we get to this, the more likely it is that there is going to be a system that is still in deployment that has one of these currently unpatched problems that is still going to be in deployment then, that may become an issue.
Yeah, last week I talked to someone named Troy, and he set up a more official initiative with ITU, I think. It's the International Telecommunications Union, and another organization called FOSS that cares more about security issues. But if you have these SSL certificates that are supposed to be expired and then suddenly they're not expired, that can be a security issue as well. These things. So yeah, but safety definitely can be involved. And where was I?
You're talking about security, SSL, expiry.
I talked to him, and
someone named Troy set up a thing.
So they want to get more people involved in these things and ensure that more large organizations get involved in like governments and in enterprise. If you have an enterprise and you rely on IT somewhere, and every enterprise does, then you want to just keep it working and ensure that it keeps working. And for that, you want to go to your vendors and say, hey, vendor, do you know if your software is safe for running past 2038? And then the vendor has to go to its sub vendors and sub vendors and figure out if they are sure what's in there, or maybe they have also source code because it's an open source product, but there can be complicated supply chains. If you've ever looked at Android, there's these chip makers and board makers, and so you have different vendors for different parts of systems, and can be complicated supply chains for some things.
Yeah, one of the things that you included in the list of topics was whether or not governments, enterprises should mandate that vendors certify 2038 compliance. I'm assuming that you're possibly in some sort of favor of that?
Yeah, I think they need to at some point. Because would you buy a device where you don't know if it keeps working until next year? So that's like on food, you have your best before date. So okay, I can still use it tomorrow or next year. And you want to know how long is your device good for use. And for some, there's these Pixel phones where they say, okay, we will supply updates for this many years. And that's good to know. Because other vendors don't supply this information. They just give you, oh, here's hardware. It's already outdated when they give to you, and they never update it. They had that with some Chinese vendors.
Running up to the 2000s, I don't know about Europe, but I know the US government was throwing money at that problem to try to fix the year 2000 problem, to basically make sure it didn't become something that was that big of a deal, right? I assume things maybe happen in Europe. I actually have no idea about that.
Not yet.
Well,
so
with the
at
year
least
2000 problem, I don't know about with the current problems.
Okay, I'm not sure. So I was in university back then, so
Right.
I only saw it on the side when people made a big deal about it. And no, your video first was
Oh, yeah, it's done that a couple of times. I could still hear you, though.
Yeah, works fine. Yeah. So I expect there will be mandates to ensure that the software they procure to use for the next years will be good to use for the next years, and especially you can't always rely on vendors to still be around, or except if this other initiative gets hold, where you want open source for what you buy. That's called public money, public code. You've heard of this initiative?
It vaguely rings a bell.
That's from the Free Software Foundation Europe, I think, where they say, oh, these governments, they spend so much money on software, public money they spend on software, so why not say, if something gets built for us, then please get the source code for us so we can have it if the vendor goes down, or if the vendor says, oh, that's too hard a problem, we can't fix that, then they can take the source code and have someone else have a try on fixing this thing and throw money at it. And that's a really good initiative, and that can also have this issues with year 2038. Because then at least you have the sources, you can recompile it and do things. Yeah, but even if it's just a binary and you run it on your libc, then maybe you can just patch your libc and be fine. So there might be ways without source code, but it's nicer with source code, really.
I think the first step to getting any sort of change happening here is to at least get people knowing about the problem and, talking about this issue. This is why I'm kind of glad that, like, every year you put out that post, hey, here are the problems that exist, here are the ones that have been dealt with, and why I've been covering it for the past couple of years as well, because I do think that this is a problem that is really important, and maybe there's, like, some developers here and there that are fixing problems, they spot them, but it's not something that there is this sort of wide initiative to fix, wide initiative to discuss. It's kind of just there's people here and there doing things, and that's basically it.
Yeah, but it's a good first step because people are more and more aware that this problem exists and that they need to not throw their time key into an int and send it around. So yeah, every bit helps. So maybe that's already enough to get half of the issues fixed. So when it comes to spending a lot of money, then we only have to deal with half the number of issues. So it helps. I'm a bit nervous.
I was gonna say, have you considered taking the topic to do a talk at FOSS or something like that?
Troy did. He ran a buff at FOSS last Saturday, I think.
Oh,
And I didn't hear back from him, so but I assume he was there and people attended and they discussed all these things that we discussed right now. Yeah, I did discuss before with him, and I collected all these reasons why 2038 will not be a big problem. And one reason that appeared in some of these Reddit posts in the past was, 2038, maybe there will be nuclear apocalypse until then, and we don't have to care about it.
Yeah, I saw so many of these comments like, look, very well, there might be, or, we can talk climate change. Like, you can talk about any of these just, like, world-destructing problems. Like, sure, fine, okay.
Yes, there's other important problems, that's sure, but exactly. We can't rely on the nuclear apocalypse to solve this.
Right.
It's not a good solution.
A more recent one I've heard is, by then we're going to have AI that's going to identify all of these problems and it's just going to magically fix it. And sure, maybe it will.
Yeah, maybe if you have the source code and can recompile it.
Yeah.
And then, it's like a good linter that can review all your source code. So maybe actually it can help, but not sure. It may miss things. It may have false positive, false negative. So, and one other funny response was, I will be retired by then. So, all fine.
Fair enough.
And do you expect to have a working society when you are retired? Do you have kids? Do you have friends?
I have no doubt that was a big part of Y2K as well. I wrote it. We only store date with 2 numbers. I'm gonna be retired by then. I don't actually care.
Yeah, but it's not good argument.
It's not a good argument. No.
We need to go in and fix these things if they are broken. Maybe it's not that much actually. So I counted, and it was in the around 60 things that I reported so far. And so maybe it's not as broken. At least the things that I see, where we already submitted fixes, but other things we don't know. There's unknowns.
Well, let alone software deployments that were written years ago. We see all of this. There's COBOL jobs that are out there, right? Like there's this really old code bases, and who knows what those code bases are doing at this point. This sort of goes more into the proprietary stuff. There's really old deployments out there. There's software out there that hasn't really been updated in over 20 years. I know someone who works in a call center that uses a DOS VM because they're still using the call center software from when everyone was on DOS. Like, this is a thing that exists right now.
Yeah, if it works, it works. So keep using it because why spend effort on it? Even if you deploy a modern stack now, you can't be sure either that it keeps working. So maybe just better off. I don't know. But our own company, SUSE, is in the business of enterprise Linux, which means we have this base version, and some aspects of this base version remain constant over the life cycle of the whole version, which can be 10 years, 12 years, 15 years. And the current release is slash 16, and the previous release slash 15. There's this extended support and extended support, and the longest version of that ends in 2037. For some reason, I don't know why.
What is the what is the longest support you can get with a SUSE version if you pay as much money as SUSE wants for it?
This is long-term extended. I don't know how the business
Whatever
term
it
is,
goes.
but there's a website for it, and the pricing depends on what's the use case and how much of the software you actually need, and that's around 15 years or something. So it varies from version to version. But usually the newer versions get longer support because customers demand it for some workloads.
But that also means that there are versions of SUSE now that people are still going to be running post 2038.
Yes, the 16 version will be supported and running beyond that date. So that's also one reason to go in and fix these things in the software we ship. Yeah, because it's our stuff we ship. Even if we don't make all of that, we ship it. And customers rely on us to ensure that it keeps working. And if it doesn't, they will call us and make us reliable. And that's why there's money to be made in prevention here. That's good because that will reduce the number of calls. So there's always this footnote when we release a new service pack, then the new service pack will be supported, and it's sort of compatible to the previous service pack. And the old service pack will then go out of support by 38. So we still have time to actually fix things, but maybe we can't do major version upgrades of some parts because that would upset customers too much, because they compiled their stuff for our stuff, and it needs to keep this binary compatibility, the ABI, the application binary interface. That's also a concern. Why, for example, for Intel, 32-bit Intel, people just keep the old 32-bit time key around, because the old programs were compiled to have this binary interface. So if they call it a time function, they expect the time function to return a 32-bit integer. So you somehow need to keep that interface as is. You can't just change it below the programs without them noticing.
So
it's tricky. It's a tricky place. I think the Debian people had a big discussion about it, and they said, for ARM, we just change it, we switch around, and we say on our old Raspberry Pis at ARM v7, which only has 32-bit time T, we just change it, and now it's 64-bit, and we recompile everything. But for the old Intel, there's so much legacy software around that they just leave it, and there's not... All the new CPUs can run 64-bit code. So even if you still run 32-bit code on these now, you don't want to do that beyond 2038. Hopefully. Or maybe you need to find another solution until then. There's this idea to redefine it as unsigned in the glibc. So for the software, the software will see this time T, and hopefully it doesn't do much processing with it. Maybe it just takes it, stores it, retrieves it, and uses it, and then it will see and use a libc function to tell, here's my type T, please give me the date and year. And then it can return a year of 2039 from the libc, because the libc interprets it as unsigned. That could be a way out there.
So what are the main kinds of problems you run into when you run into software that has problems? Is it just they're not building, or are there other things you tend to run into?
Yeah, mostly it's not building. There's one case I remember where reproducible builds really showed an issue and showed okay, if I compile this software after 2038, then suddenly I get different binaries for some reason.
Mhm.
And that was the Ceph software compiled with gem tool from the Boost collection. But it seems to have been fixed in newer versions, so it's not that big of an issue right now. But mostly I build it, I run the test, and test fail. That's what I find and where I found most of these issues. But some software does not have good tests. For example, the MariaDB issues I didn't find by building the MariaDB package, but I found it by building the Perl MySQL package, which is bindings for the server. So it runs the server at build time to do the tests on top. And that said, threw an error message and said, oh, you can't run this MariaDB server after 2038. So they actually added an error message about it. So you knew it's limited, but yeah.
Wait, sorry. They had an error message for it, but the problem was you know what? I love that. Okay, so I will at least say they identified where the problem was, but they're like, that's someone else's problem. We're just going to document it.
Yeah, sort of. But that's not the only case. There was this other case of CMake where a CMake test failed, but it wasn't in CMake itself, but CMake uses libarchive, which handles tar balls, zip files, jar files, and libarchive had a place where it said, okay, I have this timestamp here for my files in the archive, and if it's greater than 2038, then I throw an error because it's not supported. So yeah, people know there's limitations and they test for these limitations and some throw an error, and that's one failure mode.
I've got the Wikipedia page for the issue up, and there is a fun one in here where AOL server knew they had a problem with the 2038 problem, so instead of actually fixing the problem, they just set the maximum time to be minus or the 32-bit integer minus a billion seconds, so it became a problem like in 2006 instead. So I guess that's not a good solution, but they had time to fix it.
Yeah, good enough for now. Let's say so. Yeah, let's say 60 years is a lot of time to actually fix things in another round of format changes, protocol changes, and these things. So yeah, even 10 years is still some time to get things fixed. It's not like you need to rush and be busy doing nothing else now. But it's not too plenty of time.
At what point do you think this is like a critical problem where this should be first priority to fix?
I think things will start failing already in 2037 when you have like these cookies that expire 1 year from now, or SSL certificates that expire in X years from now. So browsers limited now for security reasons, but so there will be stuff that fails before, likely, and so we you can't know how early, but if you ship software, why not fix it now? Because you have to fix it in some point anyway, and if you have some spare time, go in and start fixing. Could help.
In most cases, is it like not that difficult of a problem that you've run into? It's usually just handling numbers incorrectly. Like that's what you sort of mentioned earlier. But is it usually a pretty simple fix?
Most of the time, yes. When there's binary formats involved, we want to keep backward compatibility. It can be a bit more tricky, like the MariaDB case. I think the patch was bigger. But other cases like this A to I becomes A to LL and in multiple places, and then you run a test again and find another place and iterate, and then at some point it's fine. So if you really have good tests, that helps.
And there's a problem. Writing tests are... a lot of people don't do those.
Yeah. Yeah. At some point, I also want to add it to the OpenQA testing. For every Tumbleweed release for OpenSUSE Tumbleweed distribution, we run a lot of tests where we run the install in a KVM and go through the installer and partitioning. And after the install, we run Firefox and LibreOffice, and on top, a lot of applications and tests. And if we just change the data and have these workarounds for expired SSL certificates, then we could check that all the software we cover still runs at a different time. And that could really unearth some problems that we don't see right now.
Right, yeah, doing that at a distribution level for something like Tumbleweed, which ships relatively up-to-date things, that's gonna... I have no doubt it's gonna identify a bunch of things which you probably haven't even remotely looked at yet.
Yeah, exactly. So, and even if it says all fine, that's a good thing, because then you know that you can still run Firefox and LibreOffice in 2039. And so, yeah, but there was this famous quote, I think it was Dijkstra, who said, testing can only prove the presence of bugs, not the absence.
Yeah. Yeah, I don't know if you've been paying attention to the work being done with utils, the Rust rewrite of the GNU utils. But there are, I think, 96 or 97% compliance with the GNU tests. The problem with that is all of the undocumented bugs that became features that also they need to worry about.
Mm-hmm. Yeah, that can maybe happen in some place, but I'm not sure if someone wants to rely on time overflowing.
Sure, yeah. I'm sure there's got to be I'm sure there's got to be some weird setup out there that somebody is using where something relies on it.
It makes me think of an XKCD. There's an XKCD on
Spacebar heating.
Spacebar heating. Yeah, exactly. That one. There's so often irrelevant XKCD. And of course, the other one about supply chain, where you have this one unpaid developer keeping up the whole stack of software on top of it. And that is also sort of relevant here, because there's a lot of software with a lot of unpaid developers somewhere. And yeah, at least we have their source code and we can review the source code and we can then send them patches and test these patches beforehand and have all this reasoning why it's a good change, and make it really easy to press the merge button and hopefully not have syntax error in there.
Yeah. Like, I'm sure there's gonna be weird issues that are identified further along that, especially like as you're saying, with doing it this at the distro level, I think even just past building, right? If the software doesn't build, that's a problem that you can immediately identify. The issues are the runtime issues that may not necessarily be as easy to spot, that require actually interacting with it in a certain way that's going to, I think, take a bit longer to properly identify.
Yeah, I think so. So my testing currently is really limited. And so I found issues, and it's good to fix these issues, but it's by no means complete. So
right.
I think really getting these warnings in and fixing these warnings can get us a long way, because then everything that really explicitly uses time T will be fine. And maybe there's places that handle timestamps that never touch a time T. They will not pop up in these warnings, but I hope it's not too many.
Right, and most of the discussion here has been about C, but this is a problem that can happen in other languages as well. And, you know, people handle things in all manner of weird ways.
Yeah, Python, for example. When you have your Python code, then it creates a cache file, and this cache file can have a 32-bit timestamp in there. And that part was buggy for a while, and that blocked me from testing other things with 2038. And they still have a 22-bit timestamp in there, but now they just roll over and don't care because they just match for identity. And for them, it's fine. So they have a good spec, and the spec says it needs to be handled in this way. And if everyone follows the spec, then everything is fine, even after 2106. And they're good. Python people. Actually, a lot of these issues I found were in tests for Python packages, even if the actual bug was not in Python, because the Python people have so good tests for coverage of their Python bindings for C code. That it did find runtime issues in C code stuff. And that's really nice. So good tests help.
Are there any other areas that you've sort of, or any other languages, any other areas that you tend to see these pop up in?
Not so much. So I think in Perl I only had one or two. In Python there were a couple, but not always directly from Python. And yes, C is really still very much used. So, I'm not sure what's it about Rust and Go, but I can't really remember seeing issues there.
I have no doubt people in the web space are doing weird things, though. Web developers just do weird things.
NPM and Node.js and stuff.
Yeah. And the problem is that stuff kind of creeps into the desktop with how much Electron stuff there is as well.
Yeah. Let's bundle a browser and send it out as an app. At some point, I counted in our OpenSUSE distribution how many Chromium instances we have in there. Because we have an Electron package and another Electron package and Qt web engine for Qt5, for Qt6. And so I think there were at least six
You also
Chromium
have
instances.
the, what is it, Chromium embedded framework, which is what OBS uses for its browser docs.
Yeah, so that's a couple. And so you have a lot of code duplications. And if you fix an issue in one place, then you have to ensure that the fix ripples down through the chain to all the other places where there's a copy of this code.
Right.
And
let alone the applications that bundle it. And then you got that problem as well.
Yeah, vendor targets. I can tell you stories about vendor targets. Where there's this bug, and I fix it upstream in the original sources, and then we have vendor targets of the things that go with other Rust packages and Go packages. And I think NPM also does vendor targets, and they have multiple copies of the same code in different versions and throw it into one. Because, yeah, they can do this thing with their package manager, so why not do that? Yeah, sure. Yeah, fun thing. So let's assume there's a lot of old software out there, and it keeps getting bundled for a while. And it might be not only 1 year, but 2 and 5. And that can get dangerous at some point.
Right. It sounds like you've had a lot of experience here. You don't sound very excited to talk about this topic.
Oh, I'm very excited to get things fixed. So, yeah, because if he can find these things, not for the 2038 problem, but for other things, I looked into really old code with Lisp and TCL, or TCL, some pronounce it. And it's fun doing patches there because it's understanding yet another language. It's so different with all these brackets and different mode of operation.
How long have you been involved in, well, not just in SUSE, but just in Linux stuff in general?
I got my first Linux running in 1999. And
Do you remember what that was at the time?
Linux. SUSE Linux before it was OpenSUSE. So, and from there, it's always been upgraded and upgraded. And yeah, it's quite some time. And my first open source stuff I published in 2001. I did some kernel hacking to get overlay when there wasn't no official overlay file system yet. And at some point it broke because it was a really dirty hack, and yeah, it sort of bit rotted. Let's call it bit rotted. There's so much bit rot. And yeah, in December I looked at old code where we have these old games. We have a whole collection of 700 something game packages where people have these old Rocks and Diamonds and Pac-Man and Breakout and Tetris and open source ports of these. And these were developed for very old systems with Xorg and SDL1 and old stuff. And at some point, compilation broke, and I looked into it, and I got a lot of them, dozens back working, and it's nice.
Bitrot is another one of those problems that people kind of just ignore as well. They think, oh, if I write something once, then it just works forever. And in some place, I think X11 gave people a lot of security there, because Xorg has changed so little over the past 20 years that you can run an ancient Xorg, or some ancient X11 application, and it's generally fine. But that's not how most other things work.
Yeah, Wayland is coming up, and some places are already dropping the Xorg servers. So then you have to go with X-Wayland, and they have these compatibility layers, and some things don't really work well, like screen sharing or whatever. But yeah, hopefully it will all work out in the end.
What are you personally running on your system?
OpenSUSE.
I get that much.
There's this distribution called Slowroll where I'm the maintainer of, and it's a tumbleweed where you have the space tumbleweed version, and it keeps stable for a month, and then it gets updated to the next month's tumbleweed version. And in between, there's tiny patches for security issues and other bugs that hopefully don't break too much, and usually it works well.
I didn't realize you're the maintainer of Slowroll. When Slowroll was first announced, I'd meant to reach out to someone from the project to talk about Slowroll. So, you know what? We've talked enough about 2038 for a bit. Let's segue to Slowroll, because you happen to be here anyway.
Yeah.
How did that project get started?
It got started because at some point there was some uncertainty about this whole /16 and leap16, which is using /16 binaries and sources as a base, like the kernel bash, glibc. That's all inherited, and then we add stuff on top. Like there's no KDE in /, so we add KDE on top from Tumbleweed. And there was uncertainty: will there be a /16? When will it be? How much will it contain? Will it have a desktop? And this uncertainty meant that there were two competing concepts. And one concept was this Slowroll thing, where we said, okay, we have this working tumbleweed, and it's really stable with this OpenKA, and yeah, why not get it going a bit slower? And in the beginning, I started two cycles of 8 weeks, maybe that's 2 months. So I kept the base, and it ran, but Tumbleweed is moving all the time. And when there's new major versions, I don't want to have these major versions. And then you get minor patches on these major versions and more minor patches on these major versions, and they can't take them because there's this major version already difference. So the amount of patches I can automatically pick from Tumbleweed gets less and less over time. So at some point I have to sync up and get this major version bump, I call it, to get all these new major versions and be more in sync with Tumbleweed. And currently I do it in a way where I take this Tumbleweed snapshot. It reminds me, it's the start of the month, so I need to take another snapshot. So I do that to get in sync, and then I have some more days to let Tumbleweed accumulate small patches, and then I say, okay, no, I publish it for Slowroll. So I'm always behind some days behind Tumbleweed intentionally. It also gives me some time to get the install DVD built.
So,
because, yeah.
So like how has that project been going? I don't really hear, like, whenever I hear about OpenSUSE, most of the time I hear people talking about Tumbleweed. Maybe that's just because I use Arch and I have like an audience of people that, you know, like rolling stuff. But what has adoption of Slowroll been like? How have people been liking it? Yeah, how's it generally going?
Yeah, it's let's say mixed. So there's some people who say, I prefer Tumbleweed because then if a bug gets fixed, it gets fixed there pretty quickly. And for Slowroll, depends.
Right.
So if it's really a minor patch and there was no major version update before, then I get the minor patch pretty quickly. And for some bugs, you might remember the XZ vector event that never went into Slowroll because it happened in the middle of the month and Slowroll still had the old version, and Tumbleweed did already have the new version for 2 weeks, but it wasn't yet time for another version bump, so I still had the old version and never was affected. And there were a handful of other major issues. We have this automated testing for Tumbleweed that runs in KVM. So there's things we can't test, like Intel Wi-Fi, it broke. AMD graphics broke at some point, and then it's good if Tumbleweed hits these issues first, gets a fix in, and then Slowroll users maybe never experience this breakage. So it can have advantages, but yeah, sometimes there's also bugs that are really hard to fix. It's really hard to understand where does the bug come from, how do I fix it. So the easiest would be to just update everything from Tumbleweed because we know that it's working. So in the early times, I sometimes did it. I just did another version bump in the middle of the month because that was the easiest way out of some mess I created. But in the last 2 years, I didn't need that. So at least it was stable enough. But yeah, sometimes then there's this issue with the dependencies. So I have these automated scripts that look at version numbers and is a changelog saying, oh, there's a CVE fix, and I say, okay, I want that immediately. Is it saying it fixes the bugs? And I let it rest for a day or 3, and then I pick it over. And so people need to have good changelogs. Sometimes CVEs are only published later and the fix is already in there, and then it doesn't really match up with the reality of the code. Or sometimes there was this dependency thing with Yast. People are still using Yast even if it's marked as deprecated. But just this dependency of Ruby, and it doesn't always declare this dependency correctly with versions, and then you have version mismatch. The Tumbleweed already has Ruby 4, and I still have the Ruby 3.4, and I pick new version, and it says, I need Ruby, and I say, okay, I have Ruby, and then it says, oh, I don't work with this version of Ruby. So, yeah, it happens. And then I had to downgrade it and block it for this cycle. And yeah, but it was broken for a day and people reported it, and that was a pretty easy fix out. Yeah, and there's this idea that it could become an official distribution.
Mm.
So we have Leap, we have Tumbleweed, and I think MicroOS is also pretty official, but I'm not sure how much users it sees.
So is it still considered? What is it considered right now?
Yeah, I would say beta. So it works. Sometimes your
Oh.
video is frozen. No.
Hello.
Yeah,
No,
your
I
video is
actually did disconnect that time.
okay.
Okay. I heard you. Basically, you just started talking about Slowroll. That's where I cut out. Like what Slowroll is considered right now. You said it was a beta version, and that's basically where it cut out.
Yeah. So I say it's beta. So in the automation, we don't have enough tests, let's say. So I check that package is built for the right versions, and then they go into release to users. So it's not very good, but it happens to work because Tumbleweed has a lot of testing, and I take these packages all from Tumbleweed. And the only issues that I might face are integration issues where these versions don't match up and misalign. Yeah, and it would be good to get more test coverage for that, but I didn't find the time and energy to do that. For the version bombs, we got some testings from a colleague of mine who said, okay, I am doing it. And then I throw in the new DVD for the month, and it runs a test and says, okay, it gets GNOME and KDE right, and it looks good. And sometimes we identified issues, and then I could already push the fixes for these issues before users even saw the new DVD. So that already helps, but it's still, maybe I'm just too perfectionist. I could say, here it's done, and go use it. And sometimes I look at the statistics on our download servers, and they say there's around 5,000 users. And Tumbleweed is much larger, in the 200,000 maybe. And then you need to consider that we have mirror servers, and everyone who uses mirror servers to download all their packages, they don't appear in our statistics. And then we have a CDN, and everyone who goes to the CDN and hits the hot cache, they get a reply from the hot cache and never go to our download servers and are never counted in our statistics. And so there's a chance these numbers are actually factor too large or something.
Yeah.
Yeah.
The sort of distinction between having Tumbleweed and Leap always seemed kind of weird to me, right? Like it really did feel like there needed to be something in the middle, and like I don't know what the numbers are like. I assume you have better numbers here, but I never really heard anyone talking about Leap. Like again, whenever I heard about OpenSUSE, it was only ever discussions regarding Tumbleweed. So having something which is somewhere in the middle, I think does make sense.
Yeah. The part that's tricky is so Leap is a complicated matter, let's say, because for the Leap 15 series, it became very old. This 15.6 still under support for some months. And that's based on Leap 15.0 as a base version, and that was like 7 years ago. And 7 years ago, and it still has the same bash base version, still the same whatever. A lot of basic tools that I inherited from our enterprise distribution are still in the same base version with patches on top to account for problems of one kind or another. So that becomes a problem. We had that with Ruby and Python. There was Python 3.6, and that's unsupported upstream. So we added a Python 3.11 at some point, but maybe only the interpreter and not the 1,000 modules. And so it wasn't very nice either. So at some point, it really becomes a problem that the base is so old. That's a problem with Leap. Now we have Leap 16, that's very new because it's 16.0, very recent. So currently it doesn't have the problem.
But is it going to have that problem as things progress? Like, is it going to get to a point where it's 7 years old base?
Maybe it will have a 7-year-old code base as a base at some point, and it could face similar problems, but there's a chance. We are managing source codes in Git now for the packaging parts, for the spec files for RPM, and that can maybe help make it more easier to manage things and maybe allow for more upgrades. I'm not sure how it will work out with the business sides and the enterprise users, because expectations in the enterprise can be complicated, where they say, okay, I have the systems and I want to set it up now and I want to keep it running unchanged for 5 years, for 10 years. And maybe there's this one component I care about, this Python stack, this whatever stack. And that stack, that needs to be on the most modern version, and it needs to work on this very old base. And that's hard work, getting these things to match up. And that's why we have a lot of hundreds of engineers, and they do some of this hard work.
Well, that's one of those areas where containers generally make a lot of sense to do things.
Partially, but if you have a container, do you want to keep your container 5 years old, 10 years old? Maybe not, because then you have security issues in there. So does it really help with some things? Yeah, maybe it helps that you can decouple your application from the host operating systems, and you can mix and match these things up. Right? So for the container, there's only the host kernel that really matters. And what we do is usually get a major version update for the kernel every 2 years in the enterprise space. And if that even aligns with the upstream LTS kernel, that's even better. Then we can share the maintenance burden with others. Yeah, it really helps to align there. Yeah, and for Slowroll, I think one, let's say, problem is that it really needs to stay very close to Tumbleweed. So at some point you can say, what's the difference? So why use Slowroll over Tumbleweed when Tumbleweed is so stable and there's so little difference and it's just 1 month behind? And it depends. So maybe there's not that big of advantage. Maybe there's this aspect of updates. So if you only get minor patch updates, you can be more certain that it doesn't break your workflows this month, and you can say, okay, you have your stuff on top, like your custom scripts, and these custom scripts expect certain behavior from stuff underneath it, so that only breaks once a month at most. That helps. And some people have limited bandwidth, and the next they can say within the month, okay, they get the most important fixes, and that's less bandwidth than Tumbleweed. I counted it's 30% of the updates.
I think you made a fairly good argument before that problems tend to get identified on Tumbleweed before they make their way to Slowroll, like with XZ. That never made its way on there. So in a lot of cases, and maybe it's not even that bad. Maybe it's just some sort of GPU driver regression, something like that. Things like that can be spotted on the fast-moving system before they make their... Like, you know, I run Arch, right? A lot of problems get identified on Arch before they make their way to something like Fedora or Ubuntu or something like that. And there is some value in not wanting to run something that new and letting other people that are willing to do that sort of deal with those problems first.
Yeah, that helps. Yeah. But for that, of course, you need users on the leading edge distribution.
There's people
so
that are crazy enough to do it.
without Tumbleweed users.
As you said, there's 200,000 people at least on Tumbleweed. So clearly there's someone willing to do it.
Yeah, right. No, but imagine Slowroll becoming so good and so useful that everyone moves from Tumbleweed to Slowroll. That couldn't work. So there always needs to be a balance somehow.
Right.
And Slowroll doesn't work without Tumbleweed. Because then it doesn't make any sense anymore if there's no Tumbleweed users to report issues and get them fixed.
I think you're always going to have people that enjoy living on the edge. That enjoy like things. Look, right? There's a lot of people that aren't using Linux for production. They're using it purely as a hobby. They like to play around with things. They like to break things. They like to use things that they know can go a little bit wrong, right? There's people that use Gentoo. I don't have the time to do that, but there's people that do. And people are willing to... There's always going to be at least some group of people that are willing to, like, be on something they know can be a little bit less stable, even though Tumbleweed seems to have a pretty good reputation, just because they know that they can get the latest thing and they don't really like waiting.
Yeah, Tumbleweed is really stable. So if you are unhappy with your Arch, I invite you to try.
I have Fedora people bugging me to use Fedora all the time. I don't need someone at OpenSUSE and telling me to use OpenSUSE. Well.
If you're fine with Arch, then keep using Arch. That's you're not forced to join our plushy geekos convenience.
Look, we'll see what I do in the future. I've just been running the same system for 7 years now, probably. So it hasn't broke entirely yet. So I haven't done anything with it.
So did it break, but you were able to recover it, or?
I had a faulty drive at one point. That's the only problem I had.
Yeah, that's nothing Arch or any OS can fix. So yeah.
Yeah, that's what happens when you have a lot of power outages and you're running on ext4.
ext4 is fine with power outages, right?
Usually, but if you have too many of them, things can go wrong eventually.
Really? Okay. Yeah, I might have some systems where I power them off hard sometimes. Usually they're fine.
Usually it's fine.
It has this journaling thing, and that is supposed to keep things good.
Yeah.
Yeah, so making distributions is really fun. So
it sounds like you do enjoy. It sounds like this is something that you're really passionate about.
Yeah, it's useful. So even if there were no users, I would do it for my own systems because it helps knowing what it runs and fixing things when they break, and understanding the components and the interactions more deeply.
So when did you actually find yourself working at SUSE? Like how did that happen?
That was in 2010. I would say some people in SUSE got aware of my work on OpenQA because I started to test this the thing before Tumbleweed. It was called Factory, and Factory just got the latest shit thrown in, and it broke so often. And I joined the testing team, and in the testing team, we split our tasks, and I said, okay, I want to test the installer, and testing the installer meant downloading 4 GB ISO over a line that back then was at most 50 megabit. And with at most 50 megabit, it takes at least half an hour or something.
I wish I had 50 megabit in 2010. I think I was running 2? Something like that. Yeah. Australia didn't have good internet until very recently.
Yeah, exactly. So imagine you have 2 megabit, and then you start to download your ISO, and when you're done, you find that your rolling release distribution released an ISO that doesn't even install. Yeah, fun. So you can't even test the installer properly. So then I started this automated testing of operating systems that pulled the ISOs on a server that had a gigabit connection, and then it could run these tests at night with a scheduler. So in the morning, I looked at the videos that it produced and saw, that one worked, the next one didn't. So I could see, okay, here was a breakage exactly on that date, and that helped in bisecting problems. So you can see only these 5 packages got updated, and 4 of them are harmless. So you can see, oh, this one package had a change log of, we changed exactly the thing that broke. And that helps a lot in pinpointing breakages. And later on, when others took over this OpenKA from me, they added pre-integration testing. So before things get merged into factory, they run a staging project, and in a staging project, they only throw a small set of packages that somehow belong together, and then these get built as an ISO and run through these tests. And when the tests show green, then they can get merged. And after a lot of staging gets merged, then there's another big round of testing on the big ISO again. That covers more things and might show more issues. So that really helps in ensuring quality. Modulo, the Dijkstra quote from earlier about being only able to prove presence of bugs. But yeah, but again, we can show that certain things work a certain way we expect. And whenever there's a test showing something didn't work out as expected, it might be that actually the test needs updating because there was a Firefox version update and now it's supposed to behave differently. And but sometimes you find actually bugs in software, and we have found a lot of bugs in the software. Oftentimes now before we even integrate it or before we ship it to users. So then in the latter case, this got integrated, and then we saw, oh, it's broken now, so we don't ship it, and then Tumbleweed doesn't get updated for a day or 2, or maybe 5. So I think the longest run was a week or 2. So it's 2 weeks no updates. It's really, really long for Tumbleweed. But most of the times we have like 5 snapshots a week. That's a very good number. And then it keeps rolling. And Slowroll, on the other hand, depends on Tumbleweed rolling, because I want to keep some distance from Tumbleweed. And that's really hard if Tumbleweed has these big jumps already, and then I can't have these small incremental updates.
So how does the Tumbleweed update model actually work? Well, it's rolling, but is it just... You said there were snapshots there, so it's not just bringing in packages as they are ready, or how does this work?
Sort of. I'm not very involved. Slightly.
Okay.
I know the 2
Fair
people
enough.
who do the merging, and I think they do merging rounds. Like you have all these stagings, and the stagings have their tests run, and the tests show green, and that means it's ready to be merged. And then they have multiple of these, and they say, okay, merge this collection, and this other, and that 5th one that's not yet ready, that waits for later until it's ready. And so I think they do batches. That gets integrated into this project called OpenSUSE Factory in our build service. And that gets built, ISOs fall out, and this gets thrown into the automated testing. And there's one big ISO once a day. So when that shows to not work, then it needs another day until there can be a new good ISO.
How far how far of a gap do you try to keep with Slowroll?
Some days. So it really depends. So for CVA updates, I usually get updates on the same day. Right. Sometimes even an hour before Tumbleweed, because for Tumbleweed we have a mechanism where everything is ready. It's on our staging server. The mirrors get synced, but it takes some time for mirrors to sync. So we delay an hour or 2, and for really big updates, some more hours. And for Slowroll, I don't have this delay, so I pull this update because I know it passed testing. I see there's a new version, it has a CVE fix. I pull it over. I build it for the packages I have in Slowroll. I publish it, and it can go out an hour before Tumbleweed. That has happened. yeah, that's for the very fast pass of CVEs. For other bug fixes, minor bug fixes, that's 1 day, 3 days. So I'm not sure what the script says right now, but it seems to work. And then the really big versions, they wait for the monthly update, for the monthly sync, where you really get everything.
Right.
Yeah, because sometimes there's these things, tool chain changes. When you have a new glibc, a new compiler, and you want to really everything to use that new thing, you have to rebuild everything.
Right.
And that's not something I can do for Slowroll. So that's a known limitation. And for one cycle, that has bit me a bit in the behind when I tried to update the KDE stack, because there was some Qt update needed, and then I had to update also Qt stack, and there's a lot of Qt applications, and they have these private symbols that are supposed to, not sure if they're even supposed to be used, but some programs use these private symbols, and they're very specific to a specific version of Qt, and then you can't run this old binary with a new Qt or a new binary with the old Qt. So you really have to match versions, and that was a mess. And I was happy when I could do the version bump and have everything really in sync again.
I feel like we talked about all the 2038 stuff like 40 minutes ago. So is there anything else you wanted to really add to that, or anything else you wanted to add about Slowroll?
There's so much fun things. But yeah, it's in the technical details. I'm not sure how technical your viewers are.
If you want to get technical or anything, yeah, go right ahead.
Yeah. Not sure. I'm a bit exhausted.
That's fair. That's fair. Most people aren't used to doing a long form discussion. So I guess if there's nothing else you really wanted to touch on, we can start to wrap this up.
Yeah, that's fine.
Okay.
So,
I guess. Do you have like a blog or anything, or do you just want to direct people over to OpenSUSE?
I don't have really a blog. There's News OpenSUSE where we published one article about the 2038 thing, but it's not usually about other things.
Sure. Can we expect to see another post next year regarding 2038?
Of course. I already have a schedule in my calendar as a yearly reminder. Otherwise, I would have forgotten about this. Yeah, I have so many reminders about things.
Hopefully, the tumbleweed stuff can happen, so the things can be found at a larger rate. That would be very nice. And hopefully we don't suddenly discover there is a lot of bugs. That would be good. Maybe it's not good. Maybe it means the testing isn't great, because maybe there's bugs that we're not seeing. But hopefully it's good.
Yeah. That reminds me. There's a way to find out how many bugs are in something. That's by introducing intentional bugs and looking how many of these are found in review, for example. And let's say you add 10 intentional bugs and 5 are found in review, then it means if they found 2 or 3 other bugs, that there are actually 3 more bugs that they didn't find in review, because that's around the ratio of things that get missed in review.
Huh. Okay. I'd never thought about that. Huh.
Yeah, but of course we don't want to start adding intentional bugs
Sure.
to software.
So, yeah, I guess check out Slowroll then. Can people just get that on the OpenSUSE website?
Yeah, it's a bit hidden because it's not yet official, but on the wiki we have en.opensuse.org/portal: Slowroll with capital P and capital S.
Very,
maybe you
very
can
good link
just
to find
Google.
stuff.
Yeah, maybe you can just Google it. I'm not sure. We have this get.opensuse.org thing, but I'm not sure if it's on there.
We'll find out.
But at least you can use Tumbleweed. It's nearly the same. And
no, it is not there.
yeah. So we hide it a bit because it's still in progress and we don't have good testing for these updates. But if you like to use it and value the advantages of having less downloads within the month, that can be a good match.
Okay.
Yeah, for the years 2038 problem, if you're a developer, you want to look into your code for time t occurrences, and if you're a government official, you might want to look into wanting software to run in the future.
That would be nice, yeah. I don't know why my camera keeps freezing. It's been doing this the entire time. The audio's been fine, but Jitsy's just not happy with my camera today. I don't know.
Yeah, it's day.
Yeah.
And we don't even have 2038 yet.
They're trying to shut us down.
It's a conspiracy,
shut us down.
They don't want to know. They don't want you to know about 2038, so spread the word, people.
Nothing else you want to direct people to? Just OpenSUSE, worry about 2038 problems, fix them if you find them.
I'm not sure if there's a good write-up yet, but we have the Reddit posts. The Reddit post is pretty good. It has some example patches and bug reports, and some of these are still open. So if you like, you can ping the memcached maintainer about the thing that's still open since 2023, and he said he want to take a good look, and maybe he just forgot.
Hopefully, I can not be the only person making videos about this. Maybe, I don't know, look, people like round numbers. Maybe 10 years I can convince other people to talk about this as well, and we can get some noise about this.
Yes, let's make a big anniversary in 2028. We schedule a meeting for the 19th of January, and then we do a big discussion round with all the YouTubers that do anything about tech.
I like this plan.
Yeah, I think it's enough time to plan ahead, and we can do a small round next year for January the 19th and raise awareness, and then the next year we go really big and everyone talks about it, and hopefully by then we have the GCC patches in, so it becomes much easier to just see the warnings and mark them as errors. That would be nice.
That would be nice, yeah. Make everyone's life a little bit easier. So, yeah, I guess I'll do my outro and then we'll sign off. Okay.
Then do that.
My main channel is Brody Robertson. I do Linux videos there 6 days a week. Sometimes I stream. Don't be streaming lately, but I'll get around to it when I get around to it. I've got the gaming channel, Brody on Games. Right now I'm playing through Shenmue, and I've maybe done with Silksong by now. I don't know. Whatever going on in that slot, check it out. There's things happening there. If you're watching the video version of this, you can find it on... if you're watching the video version of this, you can find the audio version wherever you find audio podcasts. There is an RSS feed. Search Tech Over Tea on whatever your favorite podcast platform is, and you will find it. The video is on YouTube. Also, we have video on Spotify if you like Spotify video for some reason. I don't know why you'd want it, but it's there. I'll give you the final word. How do you want to sign us off?
Yeah. Be good. Have a lot of fun is the OpenSUSE motto, so do that.
Fair enough.